talk today is all about future-proofing the HetNet, what we need to consider when we're doing that. My name is Paul Clowes. I'm the Senior Business Development Manager for Comba Telecom. For those of you that may not be aware of Comba, we are a Tier 1 base station antenna supplier, and along with Wireless Enhancement Solutions, which is a catchy title for repeaters and DAS solutions for in-building tunnel and stadium coverage. We're in our 21st year of business, and we have a good turnover of $700 million. And importantly in this industry, which is quite rare, we are profitable, which is very good news for us indeed. So without more ado, I have to do the obligatory presentation on the Comba. We'll talk about HetNet. So what is a HetNet? For those of us in the industry, we tend to think of a HetNet as being a microcell, picocell and a femtocell layer. That's what we think is a HetNet. However, for users, they don't even know how to spell HetNet. And to be honest, neither do most of us, which is why we shorten it to HetNet from heterogeneous network. Okay? So what we're talking about from a user's point of view is they need seamless coverage, ubiquitous coverage, taking them from indoors to outdoors and vice versa. There's no point thinking about it all being all outdoors anymore. Most of the traffic is being generated indoors. So, 80% according to ABI of the traffic will either terminate or originate indoors. This means that the indoor coverage solutions that we have today are going to have to allow greater number of connections, more diverse types of connection. We're not just talking about people to people, mobile phones, data, emails, the rest of it. We're talking about machine to machine. My fridge tells me my milk is out of date. Autonomous delivery vehicles. Now we use autonomous delivery in our R&D facilities manufacturing in China. Autonomous delivery, Amazon have been testing drones. Then we also have machine-to-machine asset tracking, positioning, beacon, RFID. So the HetNet solutions that we're looking at have to be able to cover all of these technologies for all of these usage, each with their own importance on reliability and on resilience. So the evolution of in-building systems. We started off nice and simple. Mobile phone from the 90s, early 90s. Those of us that use, I'm not surprised we still have any brain cells left, considering the power output that these had. So in the macro network, we didn't really worry too much about building coverage. Frequencies were nice and low. It got through everything, got through every medium we had. We now moved into our present day technology, smartphones, iPads, apps, machine to machine, active DAS. Wi-Fi offloading was a big thing a few years ago. Now it's real. All the mobile operators are offering Wi-Fi calling. Where I live, I have mobile coverage. It's a little bit shaky. Most of the day, my phone reverts to Wi-Fi calling. But what about the future? We talk about future-proofing the HetNet. So, various terms, we all know data is increasing. People are saying, well, it may hit the top of the curve. Personally, I don't believe it will ever hit the top of any curve. The Prime Minister of New Zealand this week became the first world leader to do a presentation by hologram. Some of the demonstrations that have been doing, they're looking at 45 megabits to deliver hologram meetings. So that data is just going to increase. Now we're talking about 110 exabytes of data. It wasn't so long ago people were asking, well, what's a petabyte? To put it into some context, 1 exabyte is round about 245 million 4K DVDs. That's an awful lot of data that's being generated or terminated within a building. That's got to be carried. IoT, smart city trends. This is all becoming major news. Now we've got smart meters everywhere, being touted as saving consumers money. So you've got IoT, smart cities. People are looking at smart city who have a smart pole solution. That provides base station coverage, Wi-Fi for municipalities, and signage. So I'm not going to spend too much time on data. We all know. No one could have predicted it would grow at this pace. It is growing. It's not going to stop. So future evolution, what we're looking at is future of indoor HetNet is going to face exponential data growth. And it's not all about the amount of data. It's about the number of connections that these networks are going to have to service. So we can build small cells today that will handle 256 connections. It's not going to be sufficient. Everything is going to be connected. There's going to be 2 or 3 connections to every device. And we're looking at a diverse and high availability connectivity. These connections are not just going to be talking about data, mobile communications. There's going to be critical communication elements in this, things that require really high reliability, not just talking about packet data, a few bytes here, Sigfox, a few bytes that gets through the data. Now, more diverse technologies. We're looking at LTE-M for machine to machine, LTE Advanced. Laura, who knows what's going to be coming into the future? And more machine to machine. That could be, we think of machine to machine being robots, automated cars, but there are far more machine to machine communications than we can really think about. Barcode tracking. Now if you get a delivery from Amazon or whoever, now you know on your smartphone where the driver is, and that's generating data. In warehouses, Amazon are already testing drones. As said, we have robots within our warehouse that don't follow traditional tracking. They will go from point to point, taking the best route, taking finished goods and products within our facility. And that's generated more data that's got to be carried within the HetNet that is the in-building coverage solution. Medical facilities. All of these things are generating more and more data than we could ever have imagined. So what's in the HetNet toolbox? We have traditional DAS. And people are saying, well, it's big and heavy. It has its place. We've got digital DAS. Well, there's a lot of push at the moment on digital DAS systems. This will be potentially the future of DAS. This is going to be the DAS of the future to allow expansion, continuation of DAS solutions, and provide greater coverage and capacity. Centralized DAS. Digital DAS moves us nicely into a centralized DAS. Some people call it cloud DAS, centralized DAS. It's still DAS, it's just where do we put the conditioning unit and the controllers. Small cell. We're at the Small Cell World Series Summit. Small cell has been talked about for a long time. Now it's actually really happening. 5G is happening. So small cell, is 5G going to become small cell? We don't know yet. And then we've got the repeaters. Traditional mobile repeaters, take a donor antenna, just distribute the mobile signal within the building. And Wi-Fi. We cannot forget Wi-Fi. So what's the answer? So how do we deliver it? Well, there is no single solution that fits all the needs. Yeah. Wireless enhancement solutions have to provide this ubiquitous coverage that I've mentioned. And each of these solutions will have a scenario where it's best fitted. Multi-operator, multi-band. We've talked about spectrum sharing in different presentations. So it's got to be multi-operator. Gone are the days of operators investing in a DAS solution for a building. There's no revenue for them. That's the challenge. Multi-services. All the different technologies. Scalable, above all else, scalable. Data's going to grow. It has to be scalable. It's never going to meet the demands on day one. And we're even talking now of 100 gigs for 5G. Now, I know those of us of a certain age will know that 900 meg mobile and NMT 450 would get you anywhere. Even the frequencies we're using today in LTE have very poor building penetration. Environmental efficient buildings, great for the planet, really bad for RF. Low emissive glass, it's a metal film glass. Typically 25 dB. Loss going through a pane of glass. You're not going to get much RF through. Foil-backed insulation, exactly the same. We're making our buildings appear to be Faraday cages. And the higher frequencies, there's nothing going to come through from the outside into the building at these higher frequencies. Oh, and new buildings are even worse. So we have to have this HetNet that allows ubiquitous and seamless coverage from indoors and outdoors, and vice versa. So how do we build a future-proof HetNet? So today, and this is no criticism of how we've been building DAS or building what we consider to be a HetNet for indoor building, it's just an organic growth. So today, first operator puts his BTS in the basement, puts a traditional DAS system in potentially, and he distributes remote radio units around the infrastructure. You could have your office block and an entertainment complex connected to the office block for the evening, traffic moves, and it needs a connection into the core. Second operator comes along. I would also like coverage in that building, please. So he builds his network, another overlay within the building, another impact on the building infrastructure. I've talked to somebody yesterday and said, well, this is great buildings now. They all have cable risers, fire stopping. And he said, yeah, after 2 years of a building being used, the fire stopping's disappeared because so many people have pulled cables in. The fire stopping between the floors is non-existent. So we're compromising the safety of the building if we don't think about this. Third operator, you can see where I'm going with this, surely. So I've now got 4 connections, possibly 4 reasonable speed connections. I call it a cloud, call it a core, call it whatever you wish, but my BTS needs to be connected to something to work. Whether that's a fibre backhaul, a microwave backhaul, whatever backhaul we're using. I then go into small cell solution. Great. I need another small cell solution. My frequencies are increasing now. I've used my DAS traditionally. More small cells, Wi-Fi, see where I'm going. Critical communications, fire alarms, sensors. You can see the amount of traffic that I'm now, number of connections I'm generating back to the operator's core, to a CCTV network. CCTV network pops in there nicely. Now the world is going critical comm, security very conscious, and the more we can do to provide a security network that is not visible, it's less intrusive, people will relax, and we can get on with our lives. This is just a case of the world we live in. So we've got all of these connections coming back into cloud core, whatever you wish to call it. Challenge here is I have no backup. I have no resilience. So when the local utility walk down the road with their JCB, they dig it up because they've got a water leak or electricity cut. They dig through this trench or this conduit, trunking, whatever it's conducting with fibre. They take all my services off. So I've got all of these services, and these are not cheap, expensive lease lines potentially from one of the incumbent operators. So that is how I believe, and how Comba thinks, we do not wish to build a HetNet. So that's what's happening today. And it's no criticism of what we're doing, it's just that we are organically growing and technology is changing so quickly, we're throwing in more and more equipment, and we don't have the money, and we need to sweat the asset, so we don't want to pull anything out. So let's look at a different way of doing a HetNet. If we could say, okay, roll back the clock, we're building a new building, how do we want to do this? And this is where, I don't know if we've got any building property managers in here, or people looking at property construction. I've seen a few around. We start off with the network and core connections. Network and core connectivity. I have my primary route, I have a backup route. This can never ever be too big. Yeah? It's not long ago that we thought 512, half a meg ADSL was a reasonable internet connection. It's probably, 12 years? Now we're looking at 8 megs minimum, 10 megs. Many of us probably have a lot more than that. Some countries are looking at 100 meg. Australia started to roll out an NBN network, trying to push a gig to every home. So this pipe can never ever be too big, let me stress that. So that's my building. I put my core in, I connect it to data centers, 1 data center, 2 data centers to give me resilience. I can help split that cloud or core wherever I wish. I then look at the building infrastructure. Similar concept. Big, fat, fiber optic, structured cabling pipes. Big difference here between the previous drawings and what we see now is everything's in rings. I have protection, I have resilience. I can provide not only capacity, I can provide protection, I can provide resilience, I can provide the security that highly critical networks are demanding. Autonomous vehicles, autonomous delivery, if they lose a connection, what's going to happen? Right? We've seen what happens with some of the autonomous vehicles in the US when people take their hands off the wheel and decide to watch your TV. It doesn't end up too well. So now, and this is probably moving slightly into a different way of funding a DAS system or a network infrastructure or a HetNet, whatever you wish to call it. Because you're looking and say, okay, network operator number 1 says, I'd like service in your building, please. So he can either say, I want service in your building, or you can go to him, if you're a neutral host, and say, I can offer you service. I can offer you 99.99999% reliability of that service because I have everything backed up. You get the operator's business because if he's going to put his name on something, he wants reliability. So all you do with him now is you start plugging RUs into your core. So we're using a digital DAS system at this point. So we've got this fiber optic core or structured cabling core. Second operator comes along, exactly the same. I've not put any additional equipment into my base unit here. All the really expensive stuff is going into the core. And that's where I've got highly resilient power supplies. I harp on about resilience. And that's from experience. I've rolled out mobile networks around the world during different parts of my career. And the number of times I've seen major switching sites go off air because of either a generator catching fire, fibre getting dug. So people say, I've got resilient fibre. Yeah, you have. Down one duct, down the street. It's not resilience. Small cell network builds up exactly the same. I've not touched anything here. So this space, I don't have to worry about putting equipment into this space. I've just got a data rack here. I don't have to have masses of air conditioning. I don't have to have masses of power to handle the power requirements of BTS. This is all done at my data center, which has huge connectivity. I can keep adding small cells. Again, you get this picture, hopefully. I don't have to touch anything. If something happens here, I've got resilience, I've got backup. And this is how we build a HetNet. This is the HetNet of the future. Everything is connecting into this central core. Importantly, we need to know about transmission capacity. Never have too much capacity. Never have too big a pipe. In-building infrastructure. We have that. Synchronization. It's been up there on the last 2 slides. Something I haven't mentioned. So far to date, many of these in-building solutions have been operating in their own little micro bubble, not necessarily considering the time of the outside world. So what's happening is this little micro bubble could be thinking it's Tuesday. The network outside thinks it's Monday. You go outside, what happens? The calls drop. There is 0 chance of handover if you don't have timing and synchronization. And this is where moving into the HetNet of the future with digital DAS, digital repeaters, we can provide timing, synchronization, the level of synchronization that is necessary to ensure that we have handovers to the outside world. Key takeaways today, through, again, no criticism, it's a collection of disparate networks. because that's how it's organically grown. So how do we future-proof it? We centralise, we consolidate core functionality. As a term that the operators love to use, and it's called sweating the asset, getting the most out of it because I'm reusing it. It allows me to shift capacity with a centralised DAS system. It allows me to shift capacity from my commercial buildings in the morning to my residential, my entertainment complexes in the evening. We ensure that the infrastructure meets the needs. That's any building owners, if you're talking to building owners, make sure that they're following these guidelines. Building resilience, mission critical will demand that. In the US, they have a rule now, I think it's everything over 10 floors must be signed off by an inspector, and it must have a critical communications network. Comba is supplying the repeaters into that network that allow them to get sign off on the building. So it's just a repeater to ensure that they have blue light communications. You can never have too much bandwidth. I've said it several times. Harp on. I've designed networks. We run out of this day one. That's what we want to avoid. I feel sorry for this chap. He's not the only chap to have done that. I'm sure many of us have that. That's the future. Something nice and tidy, core, structured cabling, designed from day one. So if we're looking at the future, we build out high capacity cores, we build out high capacity infrastructure, and we use that to provide connectivity for the various services, whether they be the small cell, the 5G DAS, the Wi-Fi, CCTV, critical communications. We can use the whole HetNet for everything. It provides high resilience. Thank you.